We want to find the force on a square root of 2 Coulomb charge at 0, 1, 0 due to two other charges. They are both 2 nanocoulomb charges at these two locations. To start any of these problems, you should begin by drawing a picture. The 2 nanocoulomb charges I will call Q1 and Q2, located at position vectors R1 and R2, and the square root of 2 Coulomb charge I'll call Q, and it's located at position vector R. So position vector R sub 1 is minus 1ax plus 2ay meters. Position vector R sub 2 is 1ax plus 2ay meters, and position vector R is 1ay meters. We will need the vectors that point from Q1 to Q and Q2 to Q. So the vector pointing from Q1 to Q is R minus R sub 1. The one pointing from Q2 to Q will be R minus R sub 2. So plugging in our expressions for R1, R2, and R, we get this result for the two vectors R minus R1 and R minus R2. And from the drawing, you could have just written down these results. So this vector pointing from Q1 to Q is minus 1ay plus 1ax. And this vector is minus 1ay minus 1ax. From the symmetry of the configuration, we also know that our end result will not have a component of force in the x direction. Let's first look at the magnitude of the force on Q due to Q sub 1. So we just write Coulomb's law. We have our constant, the product of the charges, and then we see that the distance between the charges is square root of 2 meters, so we have square root of 2 meters squared. Now we can add in the direction of the force, and the direction will be along the vector r minus r1, so we want to find a unit vector in the direction of r minus r1. So that unit vector is r minus r1 divided by the magnitude of r minus r1, the magnitude being the square root of 2 meters, so that just turns this into a cubed. Since superposition holds, we can now find the force on Q due to Q2 and just add it to this force due to Q1 on Q. So here is the term for the force on Q due to Q2. So when we add them, we see that the components in the x direction will cancel and the components in the y direction will add. So after we add those two terms, we see we can cancel a root 2 in the numerator and denominator, a 2, and this becomes a meter squared. So let's substitute for epsilon sub 0, 10 to the minus 9 over 36 pi farads per meter. So these 10 to the minus 9s cancel. This meter will cancel with one of these meters. This 4 pi into this 36 pi gives us a 9. So we have 18 coulombs squared over farad meters in the minus a sub y direction. Let's take a look at these units. A farad is a coulomb per volt, so we'll get a cancellation of a coulomb in the numerator and denominator. That will leave us with volts coulombs over a meter. A volt is a joule per coulomb. So these coulombs will cancel. We'll have a joule over a meter. A joule is an energy, which is a force through a distance, a Newton meter, so the meters will cancel, and we will end up with units of newtons, which is what we're looking for because this is a force. So the force is 18 newtons in the minus y direction.